Hi everyone, welcome to the live stream.
Good morning, everyone. I trust that all of you are doing well and are excited for what lies ahead. As we gather for today's session, I would like to sincerely thank each student, teacher, principal, mentor, and parent who has supported this journey over the past several weeks. Your commitment, enthusiasm, creativity, and willingness to embrace innovation have made this program a tremendous success. We have seen students develop new skills, explore the relationship between energy and climate change, learn how to work with data, and use artificial intelligence to solve real world challenges as they have been prepared to do. You should be all very proud of how far you have come. As we approach the finals this Friday, I'm so excited, and everyone else at CZIT is looking forward to seeing you all. We are going to be having this AI Energy Hackathon at the UTT Energy Campus in Point Lisas. We are extremely excited to welcome all participating schools for what promises to be inspiring and a very memorable event. On Friday, teams will have the opportunity to showcase the solutions they have developed and compete for prizes, trophies, medals, and special awards. In addition to your overall team prizes, and I can very well say what the very top prize will be, but should we hold it back for a surprise? It is a really top quality prize. So I want to give you a too much of a hint, but it is a very nice prize for the first place, very good prizes for the second place. Very good prizes for the third place. I will have to stop at the third place, sorry. In addition to our overall team prizes, schools will be also recognized in several key judging categories: best presentation, most creative solution, best recommended solution, best use of artificial intelligence, best data analysis. We will also be presenting trophies and medals for the top three schools, special category awards, and tokens of appreciation for the teachers of the winning schools in recognition of their dedication and support. But that's not all. We also will be providing certificates of participation for all students who participated in the AI Energy Hackathon. This is a very memorable keepsake for you all. Don't worry about it. You're gonna be using this in your future endeavors. Trust me. When you're applying for a university, this is going to be very worthwhile. Every participant is a winner because each of you has invested your time, energy, and creativity into finding solutions that can help create a more sustainable future. Today's session is especially important because we will be focusing on how to use your school's electricity consumption data to better understand energy use and its environmental impact. So, to guide you through this discussion, I am pleased to introduce Mr. Donald Baldev Singh, our very own founder of the Carbon Zero Institute of Trinidad and Tobago. Mr. Baldev Singh will share insights on grid emission factors and explain how electricity consumption can be converted into carbon dioxide equivalent emissions. Understanding this relationship is a critical step in transforming raw electricity data into meaningful environmental information that can support that could better support decision making and stronger sustainability initiatives. Please join me in welcoming Mr. Donna Baldev Singh and everyone. We love you all for taking the challenge and we'll see you on Friday. Mr. Baldev Singh, over to you.
Thank you very much, Ms. Postam, Director at CZ and Manager of many things in the organization. It's a great pleasure to be here and to be at this stage in this hackathon. When we started off on this journey, we knew what we are trying to accomplish We weren't 100% sure of how we will do it, but it evolved over the time that we were planning and organizing, and it took off when the great organization UNICEF came on board and agreed to be the key sponsor. And then we got strong support out of the Trinidad and Tobago Electricity Commission that is providing the data and assistance with judging of the hackathon. We also are very happy to have as a partner the University of Trinidad and Tobago, who has given us physical space and even this virtual space to have the meeting. And as you know, the hackathon is going to take place at the UTT's Point Lisa's Energy Campus. So you will be in the right atmosphere for what we are working on. We are also very happy to have Screaming Power out of Toronto, Canada, who assisted us with developing the platform that you are going to see today, presented by Mr. Jessie Parker of Screaming Power. And we also have the Smart Grid Innovation Network out of Canada that is providing technical support and services to this hackathon. We are happy also to have on board Paria Fuel Trading and other sponsor partners who are assisting in this event. We are breaking ground, and you who are part of this will be seen as the pioneers for how we apply artificial intelligence tools and techniques in solving the practical problems we face, particularly in relation to climate change. The famous scientist Charles Darwin said, and I'm paraphrasing, the species that are most likely to survive are those that have the greatest flexibility and ability to adapt. We are facing the greatest change that mankind has ever faced, which is climate change. And you, the young people of Trinidad and Tobago, the Caribbean, and all small island developing states, unfortunately, are going to see the greatest challenges coming out of climate change. But hear what? There are tools and techniques that you could apply to make the best of the situation, and in fact, to be able to survive and thrive in the changed environment and to address the changes due to the climate impact. In this hackathon, we are introducing you to some important tools. Of course, you have introduced yourself because you have been reading up, looking at videos and so on. And on Friday, we are looking for you to come and show what you have been learning. And the bare minimum is to show up and to go onto that stage and present and talk about what you could do in your school. Beyond that, you will have access to energy data, electricity data for 1 year. And you could now use that with the AI tools to come up with some of the solutions based on your analysis. Today, I want to also introduce the concept of the grid emissions factor to you. We mentioned it before, but it's going to be really important for you in this hackathon. So I wanted to make sure that we review it again and that it is clear in your mind. So what we have been saying is that when you turn on that light or that air conditioning or use some device that uses electricity, in Trinidad and Tobago, you are causing TNTech and its generation partners to produce electricity through the combustion or the burning of natural gas at the power stations. That natural gas gives us the cleanest form of hydrocarbon power. It's cleaner than oil, it's cleaner than coal, but it still produces carbon emissions. How to relate your electricity consumption to the carbon emissions? You use the grid emissions factor. And the factor is very simple. You take your energy use in kilowatt hours You multiply by 0.65, which is kilograms per carbon dioxide, kilograms of carbon dioxide equivalent per kilowatt hour. So the result of that would be kilograms of carbon dioxide equivalent. If you divide that by 1,000, you will get tons of carbon dioxide equivalent. Why do we say equivalent? Well, those of you who have been following CZIT and participating in the climate quiz, you would know that there are several greenhouse gases which contribute to global warming by forming a layer in the atmosphere that traps heat. Carbon dioxide is the most prevalent one of these greenhouse gases and is the biggest contributor. However, there are other gases, for example, methane or methane, which is emitted from the landfills when all of our rubbish goes there and decays. That methane is several times higher than carbon dioxide in terms of its greenhouse gas effect. So every kilogram of methane that goes into the air equals to something like 23,000 kilograms of carbon dioxide. So the conversion now is to give it a carbon dioxide equivalent. And there's that factor there. So when you assess your school's electricity consumption per day, per week, per month, per year, even per hour, mornings versus afternoons, and so on, you multiply by the grid emissions factor to give you the equivalent tons, in this case, maybe kilograms of carbon dioxide equivalent related to that use of that electricity. The grid emissions factor varies from country to country. So if you have a country that has a lot of coal burned for electricity, their factor will be higher. And if you have one that has a high concentration of renewable energy, as we hope to be in the future, our grid emissions factor will go down. So remember the number, and you will use it. You can go and read up some more about it, and you will use it when you do your calculation. With that said, and keep in mind that you can post questions in the YouTube link, and we will answer them. But for the time being, I will close off my part of this, and I take great pleasure in introducing Mr. Jessie Parker, representing the company Screaming Power out of Canada. Screaming Power is no stranger to Trinidad and Tobago, because when you go to the TNTech app and you see your electricity bill, and I encourage you to do so, and then you look at how much carbon did I produce for this consumption in this period, say for 2 months. Screaming Power is the organization that presents you that data. And they do that for all 500,000 consumers of electricity in Trinidad and Tobago. I'm happy to introduce Mr. Jessie Parker, one of the technical team at Screaming Power, who is now going to show you how to access the platform, which is called the Caribbean U Energy Hub, that has been created by Screaming Power, how to access it and access your data and use your data. Thank you very much. I hand over to Mr. Parker.
Well, thank you very much, Donald, and it's a pleasure to be here and speak to you today. Today, I'm going to show you some information that you will need during the hackathon competition, and I'm going to show you how to access the information that you're going to need, and I'm going to show you some examples of how to use it. So the first thing we've done, I've gone into the URL, which is caribbean.uenergyhub.org. That's the site that we're going to visit. And you can see that it's labeled as the CZET High School Energy Hackathon. So we know we're in the right place, and we're going to sign in. So this is a secure system. You'll need a username and password to log in. And those username and passwords have been given to to people at your school who can share that information with you. I'm going to log in now, and now we've logged in. We've confirmed that we have authorization to see this data with our username and password. And we're looking at the data sets that we can use in the competition. And they're just numbered schools. So you'll be told which number represents your school so that you can find the information for your specific school. And you'll be able to download the CSV file. CSV stands for comma separated values. And if I just click on a file, it will download. So here my browser is telling me I've downloaded the file. I'm going to show you what's inside the file. This is the actual text inside the file, inside the CSV file. And it just looks like letters and numbers. And this comma here is what makes it comma separated values. So it's one value and a comma and another value. And this is a date. This would be January 1st in 2025. And a time, this is 30 minutes after midnight. And you can see that each file is, each line is 15 minutes later than the prior line. So this information is coming in 15-minute intervals. We call this file an interval file. It's the amount of energy we used in the period. So you can see in this 15-minute period between midnight and 15 minutes after midnight, this is the value of energy that was used. In this case, it's about 1/2 of a kilowatt hour. And you can see that every period has a different number associated with it. So we can work with this in text form, but it's not particularly easy. Another way to work in this is to use a spreadsheet program. Here I'm using Microsoft Excel, but you can use numbers if that's what you have on your computer. You can use OpenOffice Calc if that's what you have on your computer. And you can see it's just broken out by that comma into the different values, and all the information is here. You can see it's really quite a long file, and we're already in the thousands of lines, and we're going all the way up to about 35,000 lines. That's how many individual readings we've taken for a year of energy use. And in a spreadsheet, we can select ranges and do addition to add them all up and things like that. But we have another way that you might be interested in using this data. We have some code, some JavaScript code that I'm going to show you now. And that the way I'm getting to it is I'm saying open live demo. So this is a page that you can use online like this. You can also download it and save it to your computer and make changes. And what it does is it asks us to load the CSV file that we just obtained. So I'm going to say choose, and I'm going to choose the sample data file that we have. And this program will load all of the file. So you can see we've loaded 35,000 records, 35,000 rows of the file. And it's giving us some information that we can use to make sure everything's working properly. It's telling us that the first reading came January 1st of 2025. The last reading came January 1st of 2026. And this is again a sample file. Your real file will have a more current date range. It's also added up all of the lines. So all of those individual energy use lines, we've added up, and you can see it's quite a large number. It's over 8 million kilowatt hours in total. And we can see also that the daily average for this test file is around 24,000 kilowatt hours. Now, this test file is made up. It's not a real school at all. It's just this pattern, this daily pattern repeats over and over again. You can see that here we're using almost 500 kilowatt hours in 15 minutes, which would be a very high energy consumption, more like a factory or an industry than a school. And you can see that we've got this sort of daily curve where we don't use much at night, and then over the course of the day, we increase and we use more and more, and around the middle of the day, we're using the most energy. And towards the end of the day, then we turn off our lights and go back to bed, and we don't use any energy in the night. And this daily energy use profile you'll be able to see for your individual schools. Your schools will be more quiet in the early morning and more quiet in the late evening, and most of the energy will come in the middle of the day. So that's a sample file that you can use. And we also have, you can also look at the code. So if we just view page source in your browser, this is a common feature that browsers have. We want to say, show me the underlying code for this page. So I say view page source. And here we see things that start to look very much like a computer. And you can see we have some comments in here that are this piece of code lets us just write notes to each other. And so there are some comments that explain what's happening and give you some hints about how to use the file if you'd like to use JavaScript. And it shows, how we're decorating this file, and you can change just about anything you want here, and you can use this file changed on your computer. It shows how to load the file, and it has some tips about challenges you might like to try, like finding what was the lowest energy use that you saw in, when everything is turned off, what's the lowest energy use in a given hour or in a given period. So that's a very high level introduction to the data that's available and making some general use of that data in code to figure out things that are useful to you. So that's my presentation. And with that, I think I'm going to hand it back to Donald.
Thank you very much, Mr. Parker. Very concise, very clear. We're really happy to have your presence and expert introduction to the platform. I know you were instrumental in creating it, so we're talking to the source here right now. We appreciate that. I wanted to know if there were any questions. I think I saw one. Daniel, do you have any questions to put to Mr. Parker before he goes off?
Yes, we have one question from Elizabeth, and she asked, what tips can you give us for data analysis and visualizing the data?
Well, thanks for the question, Elizabeth. I would say that probably the easiest way to visualize the data would be to use an existing tool like a spreadsheet, like Microsoft Excel is a very common spreadsheet. Open Office Calc is another very common spreadsheet, and it's unlicensed, so you can install that without paying. And most computers, like if you have a Chromebook, for example, I think you'll have a spreadsheet installed already. And that has the ability to prepare charts and pie graphs and things like that from the data that you receive. That's, I think, the easiest way. Yeah, I think that's the easiest way.
I picked up a question as well, which was, do I have to use code to analyze the electricity usage data?
Well, it's not strictly required, no. Um, there are AI tools that are capable of taking the file and doing operations on it without anyone needing to write code. Uh, that's another alternative to make use of an AI code tool. There are several available. You might have some that you have specific access to through your school, or you might try the free versions of what's called Claude.ai, or Grok.com, or really there are several of them, and they're capable of analyzing the data files without writing code, or also without even using a spreadsheet. And they're becoming more and more useful as time goes on.
I think that's a very important tip. And thank you very much for it. And let me thank you now again once more, Mr. Jessie Parker of Screaming Power. Excellent presentation. It will be preserved for posterity on CZIT's YouTube page. And persons present here and those who missed this one can go there and pick up our conversation from today and the previous ones as well, so that you can best prepare for this hackathon. Thank you very much again. A couple of things to remember. Remember that you have a target of reducing your energy consumption at the school by at least 20% through your efforts. You can go for more, or you can do what is practical, because we are assessing the feasibility of your solutions as well. So don't say some number that is pie in the sky that is not realistic, because you'll be giving up potential marks in the competition. We look forward with great anticipation for the actual event. We thank you, all the schools who agreed to participate. We know it's a busy time with CXC exams, end of term exams. It seems there's always a busy time at the schools. We adjusted to the date of June 12th to accommodate best the schools that wanted particular gap in their curriculum activities to have the hackathon. And it's coming off on Friday, June 12th, 2026. See you there. Thank you.